In this section, we'll talk about more advanced 3D modeling in AutoCAD. So we have a pipe connector here in 3D, and it's comprised of a triangular flange at the base. It has several cylinders, vertical cylinders. Also, it has a sphere here, half of it. It also has a horizontal cylinder and an oval flange here. And on this side it has a tilted pair of cylinders that are at an angle of 45 degrees as compared to the vertical axis line. And we have to model this into 3D. To start work on this, we'll create a new file and we'll start from the AutoCAD template. Turn off the grid with F7. We'll set the units. And now we're ready to start drawing. We'll start by drawing the triangular flange at first. Then we can move on to the cylinders, then the sphere, then the tilted cylinders, and then the horizontal cylinder with the flange, the round oval flange here. So I turned off the cutting plane and the solid body so we can see how this was constructed. So it has a series of axis lines through which shapes have been created and then turned into objects, 3D objects, based on moving the coordinate system wherever it was required. And so this is the way the process works. At the beginning, you start by drawing several axis lines, and you have to have them positioned properly in order for the modeling to take place in the proper way. To start with, I created a few layers, an axis layer, an outside and inside geometry layer. And now we can move to our axis layer and start by drawing the circle for the holes. So C, enter, 0, 0, and the diameter is 80. This is for the circle for the bolt holes, and we started the circle from the origin point. And I want to give the LT scale command, so in order to see like the type of line, maybe I'll give it a 7 like that. And this being a triangular flange, it needs 3 axis lines, 1, 2, 3, because the holes are aligned at a 120 degree angle from each other. So we have one straight axis line that comes from the origin point and goes to the left, and then the others at 120 degrees. Also starts from the origin point, and if this is 40 millimeters, because the diameter is 80, we need to build this so that it intersects with this circle and also intersects fully with the future bolt hole that we need to create, and we can see that the bolt hole has a diameter here, which is I think it's 11 millimeters. So actually it's 10 millimeters. So we have it here, 10 millimeters for the diameter of the hole and 10 millimeters for the radius. So to build that, we'll go back, and so we need to draw the axis line so that it extends outside of the second radius of 10. So we need to draw that axis line to be 40 plus 10 and plus another 3, so it should be 53. So it's a line, starts from the center and goes to the left, so at minus 53 comma 0, and tap enter twice to have that. And now we can change to our one of the other layers, for example layer 0, and create a circle here, like right at the intersection, with the diameter of 10, and another one from the same point with the radius of 10. So we have these two and the axis line. We need two others here, so we'll perform an array. So give the array command, select the three objects, these two circles and this axis line, and enter. Now if you look down here, it says to choose the array type and you'll choose polar. Then you have to select the base point, which is here, and then you have to give the I command, so you have the chance to select the number of items to be 3, and you have to tap enter so that the command ends. And this is the array, but it's a whole object, so we need to explode that into smaller pieces. So explode this, and now we have the individual objects again. And to continue drawing the flange, the triangular flange, we need to draw some tangent lines. So line, tangent, click here, tangent again, and click here. Tap enter twice to repeat the last given command, then tangent here and tangent here, or tap enter or the space bar twice, tangent here and tangent here, and this is our flange here. And we have to trim this axis line, so give the trim command, and I'd like to give select the cutting edges here because the geometry is more complex, and this and this will be our cutting edges, and we can delete everything based on those cutting edges. And now, because we want to extrude this flange, we need it to be a single continuous closed loop. So we need to select these lines here, and we need to create a single loop. So by selecting them like that and giving the join command, they will become a single loop. So as you can see, they have become a single loop. Now we can switch to our isometric view from here, from the top left. So we'll switch to southwest, and as you can see, we have our flange outline here and our bolt holes as well. So we give the extrude command, but we need to know how much to extrude this. So if we take a look here, this has a thickness of 10. So we'll extrude that by 10. So give the extrude command and select the outside line here and also the 3 bolt holes of the flange. Tap enter and then give 10 millimeters. And now we have the situation of having 4 bodies that have been created, and we need this to be moved to the outside layer, and we need these to be moved to the inside layer. And if we look through the conceptual view, we can see that we have the overlap between the outside part body and the inside bodies. So we need to get rid of the inside geometry here so that we have the bolt holes visible in a proper manner and have no more intersections. So we switch back to 2D wireframe. We give the subtract command. We select the first body to be the outside geometry. Tap the space bar or enter key and then select the 3 inside geometry bodies that we want to extract from the outside geometry and tap enter. And now, as you can see, these look like they have been switched to the outside geometry layer, but actually the operation of extracting the holes happened. So now we can move and see that we have our bolt holes created for us. So set the isometric view here back to the southwest isometric. Now let's take a look at our vertical cylinders here. So we have one vertical cylinder here. It has a diameter of 50. We have another one here. We don't know the diameter, but if this is a spherical surface and it has the diameter of 36, then this has also the diameter 36. Then we also have here another cylinder which is of diameter 24, and inside that we have a cylinder of the diameter 14. So we need to create these circles on the base and then extrude them at the proper heights. So in our file here we need to switch to our 2D conceptual view, go back to our top view so we can see from top down, and make sure we're on the initial layer so we can see the geometry better. So we'll give the circle command and we'll start from the origin point. And so we need a diameter of 50, then another diameter of 36, another diameter of 24, and another diameter of 14. And all these circles will be extruded onwards to the proper shapes, to the proper size that they have to be extruded. And to do that, we need to go back to our southwest isometric view here so that we can see it better. And our first cylinder here, this one, a 50 millimeter diameter cylinder, is extruded at a height of 25. So we go back to our drawing here. We extrude this one at 25, and we'll do this for the other cylinders as well. I extruded the 36 diameter cylinder at a height of 70, and the other two cylinders of 24 and 14 at a height of 110, based on the dimensions here. From the bottom to the center of the sphere is 70. So for that 36 diameter cylinder, I extruded by 70, and then for the other two, the 14 and 24, I extruded by the total height 110 for those two cylinders. And now I have these cylinders here. Some of them belong to the outside geometry layer, and some of them belong to the inside geometry layer. So we can establish who belongs where by simply looking at the model here, and we can establish that the 50 millimeter diameter cylinder, the 36 diameter cylinder, and the 24 diameter cylinder all belong to the outside geometry layer, while the 14 diameter cylinder belongs to the inside geometry layer. So we'll switch these properly. This one and this one and this one need to be on the outside, and this one needs to be on the inside. And now if we look into how this looks like with the conceptual view turned on, we can see we have a similar body to the one we are trying to model here. The only difference is that this has already been, the diameter cylinder of 14 was already subtracted from the other cylinders, but we have to make sure that the inside geometry remains in place in this case until the very end, when we have everything on the proper layers, because here we have to do with intersections of cylinders, and if we extrude these before they should be extruded, or rather subtract these, the intersections will not align properly and will not really generate the proper curvature inside of the part. So we have to keep the geometry and place it on the proper layers and do a final subtract at the end, because they have to be joined together. The outside geometry needs to be union together and the inside geometry needs to be union together, and then from the outside geometry we'll subtract the inside geometry once we have all of the geometry in place. We'll move on to creating the tilted cylinders here. These are of a diameter 10 and 20, and they have a axis line that starts from 35 millimeters and is tilted at 45 degrees. So we'll go here to our document, and in order to do that we have to change the position of the coordinate system to make it easy for us to draw those axis lines. So we'll type in the UCS command and we'll say that we want to move it at a certain point, 0, 0, 35. And now we want the position of the X and Y so that they are facing to the right and to the top. So we'll hold the shift key and we have our X to the right, and then we'll hold our shift key and we have our X, Y towards the top, so that now we can create our axis line like that. So we'll switch to our axis line layer, and we'll give the line command 0, 0, and now we'll use relative coordinates, polar actually, at, and then I'll give 100 millimeters, less than, and now this is 135. Tap enter twice, and this is our axis line created for the two tilted cylinders here. And now we have to create these two tilted cylinders by creating the two circles. So we need to create two circles. Start from the origin point, and they are of a diameter of 10, and the other one is of a diameter of 20. And these circles need to be on the at first on the 0 layer, and then we'll move them on the proper layer. Now we'll have to extrude this, but we need a reference on how much to extrude it, and we have this height of 85 here, which is placed here. So we need to go here and create a line. So a line that starts from the quadrant, so the quadrant of this, and goes towards the top. Since we moved our coordinate system, Y is towards the top, so we can go give the at symbol 0, 85, 0, and this is where the axis lines intersect, and this is where we'll have to bring our extrusion towards, so this point of intersection here. And we'll give the extrude command, select the two circles, and these two circles are already inclined at an angle, but if we needed to rotate these, we could with the 3D rotate command. And so the 3D rotate command works by selecting the objects that you need to rotate, and then like a gizmo appears, and this gizmo will help you to select the axis lines based on the axis line based on which you will do the rotation. So for this particular situation, I have to find the proper axis line of rotation for my circles here, and that is this one, horizontal axis line. Maybe I'll have to also close my snap feature so I don't snap to anything accidentally. And the tip is that if you zoom out, you can only like select the proper gizmo easier, and you can select that, and now it's waiting to for you to give it an angle. So if you were to give it 45 degrees, for example, the circles will rotate at that certain angle. In this situation, however, the circles haven't rotated because this is an optical illusion. If we were to like tilt, we can see that we were hoping that the circles were on a horizontal plane, but they are on the vertical plane. So this is why that happened. And they were built on the vertical plane because the X and Y are positioned like that. And they are positioned like that because we set them so we can draw this axis line. So in order for the two circles to be properly placed, we need to change the position of the coordinate system again. So we give the UCS command, we switch the OSNAP feature back on, and we can click here, and now we need the X to be like that, so hold shift so it is straight at the horizontal, and Y should be like that, and hold shift and click. And now X and Y are horizontal, like they create a horizontal plane. We can create the two circles again, so 0, 0, and the first one is of a diameter of 10, and the second one is of a diameter of 20, and these two circles belong to at the beginning, so we'll switch them to the 0 layer. And as you can see, the difference in perspective is now obvious, and we can delete these two which were built on the vertical plane, and keep these which were on the horizontal. And now we can rotate them as proper. So 3D rotate and select the two circles here, and now zoom out so we can see the gizmo easier, and we can select this axis line here, no problem. And now we'll have to give the angle of 45, and this rotated our two circles into 3D, and now we can extrude them up to this point. So we'll give the extrude command, and we'll select the two and tap enter, and now we'll have to snap to this intersection point here. Okay. And we'll have to change the outer cylinder will be on the outside layer, and the inner cylinder will be on the inside layer. If we switch to the conceptual view now, you can see that our 3D part here is starting to look more and more like our objective part here. And after we built this tilted cylinders here, we will start to build our flange here and our horizontal cylinder here. Now this flange can be built in place, like right in this place on our drawing, but it also can be built on the side and moved when we want it to be moved. So this is what we'll do. We'll go to our drawing here and switch to the top view. And on the top view, we'll also want to create a circle. So the first circle we'll create somewhere here, and it needs to be of the radius 50, because the radius of the oval flange is 50 right here. And we also need to create another one which is at 30 from the first one. So we'll create another circle at 30 from this center of this one. So we'll create a circle, and we'll say first we'll draw like a helping line. So let's draw a helping line from the center of this circle here towards the right. So at 30, comma 0, and this is the point where we need to start the other circle. So circle, then snap to that point and give the radius of 50. And these lines, these two circles, need to be on the 0 layer so they can be seen better. And also we have to draw these rounded edges here, which are of a radius of 10, and the bolt holes, which are of a radius of 10 as well, of a diameter of 10 actually. So we'll go here, we'll give the circle command, then we'll select TTR for tangent radius. We'll click on this circle, place our cursor outside and give the radius, which is 10. And we'll repeat for the other side as well. So give the circle command, then TTR. Select the first tangent, the second tangent, and place the cursor outside, and the radius of 10. And inside these, we need to create another pair of circles which have the diameter of 10. And here as well. So circle, make sure it's concentric, diameter of 10. And now we need to trim everything. So with the trim command, select from here the cutting edge. We want the cutting edges to be this one and this one for the moment, and we'll cut this one and this one. and then we want to cut this and this, and we want to place everything on the 0 layer. So let's try that again. Place it on the 0 layer. Okay. The outer line here needs to be joined into a single continuous loop. So we'll select everything and give the join command to have it join into one loop so we can extrude it. And now if we go into the southwest isometric view, we can extrude these with the extrude command. This one and these two. Okay, and this has a thickness of 10, and we need to also subtract from this the holes here, the bolt holes. So we'll go into our 2D view here, subtract from this body this one and this one. And if we go back to our conceptual view, now we can see we have through holes for our bolt holes. And now we can select this and send it to the outside geometry layer. And we'll leave it at that point for now. Let's try to build our horizontal cylinder here. Our horizontal cylinder has some dimensions, like for example the inner diameter is 14 and the outer diameter is 24. So we know that part, and also we know that from the middle of the cylinder here until the outer face of the flange, we have a 45 millimeter distance. So we know these two, we know this dimension and we know these other two dimensions, so we can build our cylinder. So if we switch back to our 2D wireframe view, we can move our coordinate system once again. So make sure it's on the UCS, enter to send it to the base, and we need to move it towards the top, and we need to move it towards the top by a distance given from the center of the flange here, and we have it to be 45 as well. So this dimension from the center of the cylinders to the bottom will go here, and we'll move our coordinate system to that point. So UCS and then 0, 0, 45, and now we need to control our X and Y positions. We need them to be, the X needs to be towards the right here, and the Y can be towards the back there. And we can create the two circles. So one of the circles is of a diameter of 14 and the other one is of a diameter of 24, and we'll also rotate them. So rotate this one, so 3D rotate this one and this one. Zoom out to have the gizmo and select the proper axis line, and we need them to rotate by 90 degrees. And now we can extrude these two by 45. So select this one and this one and 45. And it went in the other way, so we'll need to give the minus 35. So extrude this one and this one minus 45. And now we need to place them on the proper layers. So this outside one, the 24mm one, goes to the outside layer, and the 14mm line cylinder goes onto the inside layer. We have most of our parts, but we also need to put in this flange onto the position. So we'll go into conceptual view to see things clearer, and if we rotate a bit, we can see the two cylinders there. And let me switch back to isometric view here. This flange needs to be rotated a few times, and then it needs to be placed here. So let's 3D rotate this flange, and we need to rotate this on this axis for 90 degrees, and we can still rotate this on this axis for another 90 degrees, and we'll exit out, and we have it in position here. We just need to move it from here to here, and this was 45 from the center to the face of the flange, so we need to have this face tangent to this face here. So let's try to move this. We'll move this flange here, and we'll try to grab the flange from its center point. But remember, we have two center points, so we can't select it from its center, but we can select it because we need to move it exactly in the center of this cylinder here. So we'll delete this line here, don't need it, and we can create some helping geometry, line, quadrant from here to the other quadrant here, and another line starts from the quadrant here and goes to the quadrant here. And we have the center of the flange. We can now move the flange, this flange, and we can snap to this center here, and we'll place it here exactly. And we can delete this geometry that we used it just to help ourselves position that flange. So we'll move to the southwest isometric view, and we can delete this line as well. And now we have to perform a final subtraction, so we get the inside emptied, and we'll be closer to our finished flange. At this point, we are about to perform the final operation between the outside geometry and the inside geometry, and it's a good time to think about if the model is okay or if we have done some mistakes. And in this case, I realized that the flange here is not properly generated. So I'll show you another way to model the flange in place. So I showed you how to model it in the in another view and then move it. But now we'll model it in place, and we'll try not to repeat and change the dimensions a bit. So I'll click on this and delete it, and I'll start working on the flange from the origin point of this cylinder, so of the circle of this cylinder. So I'll have to move the coordinate system here, and I can tilt this like that, and I'll give the UCS command to model this in place. And I'll snap to the center here, and my X coordinate will be on the quadrant of this circle here, and my Y coordinate will be on the quadrant here. So let me do that again. UCS center, click, quad, click, and quad, and click again. So now we have the coordinate systems sitting properly, and I'll create my first circle of the flange at 50, so 30 from the origin, 30,0, and the radius is 50, and I'll repeat the command and start from minus 30,0 and make the diameter to be 100, or the radius to be 50. Then I will trim these to make it easier to understand. So trim these around here. Let's see, trim. And I have to be careful how I select these, because they might be in a different plane. So trim, then select the cutting edge to be this one, and trim this one, and then select the cutting edge to be, so select the cutting edge to to be this one, and delete this. And now I'll have to create a circle using the TTR command and clicking on this, that, and giving the first radius of 10. And I can then select as the cutting edge this circle, and then trim these X's here, and then select the cutting edge to be these two edges, trim that circle there. Now I can create a circle here with the diameter of 10, and I'll have to do that here as well. So circle, tangent, tangent, radius, click here, here, and give it the radius. So the radius is 10. Then trim and select these as the cutting edge, and repeat, but select this and that. Well, not that one, this one, and not this one. And now cut that one out, and then create another circle which is here. It has the diameter of 10. Right, and now we have to join this to create a closed loop, because we want to extrude this. We create this, we join this together, and these need to be, to see them better, we'll place them on layer 0, and we have these. Now we can extrude them. This one, that one, and this one. And we'll do a thickness of 10. And it went the other way. So Control Z, extrude again, select this, and this, and enter, and then minus 10, and it came the proper way. And we can see this because if we rotate this, we can see an overlap here, and if we go into 2D wireframe, we can also see the overlap happen. And now we can perform an subtract between the flange and its bolt holes. So we'll do subtract from the body of the flange, this bolt hole and this bolt hole, and we'll put this on the external outside geometry because it belongs to the outside. And when we'll go to the conceptual view, we'll see that we have the two bolt holes already cut for us, and we also repaired the flange, and we can see that because now the flange is not up until this level, but it's higher up as it is in the initial construction. So this is why it's useful to have an inside geometry setup and outside geometry, because if you realize that you have some errors in the modeling process, you can still edit some of the elements before you do the final extrusion, the final subtraction actually. So if we look here, we have most of the elements placed. We only need to add this sphere here. So the sphere is of a diameter of 36, and we can give the sphere command, and it asks us to specify the center point, and the center point is this one here, the center of this cylinder, so right there. And now it asks us to specify the radius or the diameter, so the diameter is 36. And we have the sphere here intersecting, but we'll place it on the outside layer. And now we placed also the sphere here, and we have everything in place, as we can see in the model here. And we can move on to extruding, like subtracting the inside geometry from the outside geometry. Or we can use two bodies, like for example we can union the whole outside geometry into one body, and we can union the whole inside geometry to one body and subtract from the outside geometry the inside geometry. Or we can actually select every outside element and subtract from every inside element, however we prefer. So for example, we don't want to make any mistakes, so it is better to first union all of the outside geometry and then union all of the inside geometry. So we'll go into 2D and we'll give the union command and then select the geometry that needs to be on the outside. So the flange, the 50 millimeter cylinder, then the 36 millimeter cylinder, which is this one, the sphere, and the 24 millimeter outer cylinder, the 24 millimeter outer cylinder here, the oval flange, the outer 20 millimeter cylinder there, and we can tap enter. Some of the lines have changed a bit, and if we go into conceptual view, not much has happened other than the fact that this is now one body, and if we click on it and delete it, we should only see the inside geometry. So we have three other cylinders that we can join together, we can union. So Control Z, and now I'll go and change the visibility to off for the outside, and I can union these together as well. So they were three bodies, and once I union them, it's only one body here. If I delete this one body, all of them disappear. Now I'll turn the visibility on for the outside geometry, and also I will go into the 2D wireframe and I'll perform the subtract from the outside geometry. We'll subtract the inside geometry, and now only one body is on screen, and that is the outside geometry body, which has the inside cut out. So every thing is as it should, in the sense that the inside overlapping bodies have been removed, and all of the intersection with the outside geometry has also been removed. What we can do next is perform the chamfer edge here, which is 1. So we can go here and perform the chamfer edge distance 1, 1, and then click on the edge there, and we have the chamfered edge as well. And now if we select this and delete it, it's only one body, so it will disappear. If we want to make sure that this is properly created, meaning that geometry inside is fully removed, we can use the SECTIONPLANE command, and we need to pick some points based on which we select a cutting plane. So one point will be here, and another one will be in the quadrant here. And as we can see, now we have sectioned the part and we can see inside, and all of the inner geometry has been removed, so that we can make sure we made sure that the geometry is properly created. And now we can select this plane here and we can delete it, and the part will be back to normal.